So very good morning, students. So welcome to IIT NEET Foundation or Focus C program by Krishnaveri Talent Schools and the Mastermind Schools. So once again, welcome all the class 6th students for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 6th, our ongoing chapter, electricity. And today we are entering into the session number 5. So session up to 4 sessions we completed for the test 5 syllabus. Today we are entering into the syllabus of test 6, right? Test 6 syllabus, which is maybe on 30th December exam. So today we are going to discuss about the test 6 syllabus of electricity, where we have synopsis 3 and 4. So synopsis 1 and 2, what we covered earlier is the syllabus for test 5, which is already scheduled 25th November, yesterday. But today what we are covering is for the syllabus of test 6, which is scheduled on 30th December. So you have to cover both synopsis 3 and 4 in coming 4 to 5 sessions, right? So till 4 sessions, we cover the basic concepts of electricity, starting from its origin of electricity to so many important information related to electricity. The same will continue. We are continuing this where we stop in the last class, right? So before going to for the next topic or today's topic, once we have the glance into the total topics, what we covered, you can see on the screen. We started with what is electric charge, right? So there are 2 types of charges are there, positive and negative charges. Then we entered into what is the conductors, what is the insulators, what are the semiconductors. So based on how electricity passes through the substances, they are classified. The substances which are completely allows the current to pass through them are called conductors, which completely stops the current, means does not allow the current to pass through them, are called insulators. So there are another kind are there which allows the electricity partially or partly, are called semiconductors. Then, so when you are giving charge to a body, because you know that atom is electrically neutral. Any atom contains same number of positive and negative charges. But whenever there is a transfer of electrons takes place, they get charge, either positive charge or negative charge. That process is called electrification, the process of giving charge, right? So that electrification can be done by so many methods. Out of that, one is friction, that is by rubbing the 2 bodies, or conduction, by contacting the charged body with uncharged body. Third one is induction. Even without direct contact also they can get the charges. So by these 3 methods, we can give the charge to a body, right? So after studying about that, we have seen about the how to detect the charge, and that we have seen law of electricity also. F is equal to Q1 Q2 by R square, the famous Coulomb's law. That is when the 2 charged bodies are placed at some distance, the force between them is given by the formula, right? Then we discussed about electroscope, how to identify the presence of charges and kind of charge. So there are 2 types of electroscopes. One is pith ball electroscope, second one is gold leaf electroscope. Then we enter into the second synopsis, where we discussed about the source of current. So there are small source of current with battery or cell. So there are different types of cells are there, primary cell and secondary cell. Primary cell cannot be rechargeable, whereas secondary cell can be chargeable. So in that again, there are so many varieties of batteries you can see, or cells you can see. Leclanche cell, bichromatic cell. There is a wet cells are there or dry cells are there. So all these are gives the electricity for us, which are comes under source of electricity, right? Then we are introduced, just have the introduction about the third synopsis also, which is the, now from here, we have the syllabus for the weekend 3, that is weekend test number 4. So our test 6, our test syllabus starts from here. Remember, okay, which is on 30th December. Okay, from here. That is, we'll start from the what is electric circuit. So, you know, circuit is nothing but closed one. For example, circuit may contains, one is suppose say bulb. I'll say this has a bulb, right? The second one is source. Suppose say this is a key or switch. Then we have the cell or battery. All these are connected through wire. So like this current flow. So bulb will glow. So whenever switch is on, switch on, switch. So these four, one is, this is called source, which gives out the current. This is called consumer, which utilizes the current. This is called switch, which is used to on and off. And this is a wire. So when switch, source, consumer connected through a wire, such arrangement is called a simple electric circuit, which is commonly you can see in our house also. When you go to home in the night time, when you switch off the light, switch on one place, light will go other place. Or switch on the fan, it will move. Why it is possible? Because they are all connected through a cable in the form of a circuit. Right? So simple circuit. And in circuit, you can present some symbols also. You can see here. Symbols of the components of circuit. So what are the main components of circuit? One is source. It may be cell, or it may be battery, right? Or it may be inverter, or it may be generator. Large cells are this generator. They are comes under source, any one of these. Whereas consumers, you can say bulb, fan, AC, fridge. You can say even kettle, anything which uses current, or it may be geyser. So many are the computers. All comes under the consumers. Switches, you know, so many varieties of switches are there we can use, right? And wire. This wire should be a conducting wire. Must be conductor. Maybe copper generally will use. So even you can use the gold also, silver, because they are very good conductors, but we cannot bear the expenses. Generally, copper is used as a wire, conducting wire, right? So all these three are connected through where use the, see, because symbols also for some components they given. Cell. Cell is represented by one long wire and one short wire, like this. Long wire is called positive, short wire is negative. That is called a cell, right? So after the cell, there is a battery. When more than one cell is connected, one or two, more than one, it may be 2, 3, anything. Like this, if you connect, they are called positive, negative, positive, negative, positive, negative. This is a symbol for battery. Battery is nothing but combination of cells. Then we have the key. Key you can represent two ways. One is like this, or one is like this also. This is also symbol for key. It is open key. When you close this one, it is a closed key. Right? Similarly, another word called resistance, just like a speed breaker. Resistance is nothing but which controls the flow of electron. If current comes, high current, to control that, there is a resistance is used. Every appliance. Then fuse, you know, what is the importance of the fuse? We'll learn later. To control the over high voltages. When high voltage comes, to protect our appliances from damaging, we'll use the fuse. And bulb, symbol for bulb, what I shown here. Okay. So these are the some components. There are so many components are there. The some components which are represent the circuit are this, which is comes under the electric circuit. What? Electric circuit. We will start from here for the test number 6. Okay. So as you move further. So what are the main components of circuit you can see here? First one is cell. Cell is the very important, which is the source of current. A small source of current, right? A cell is a small source of current. So it supplies the electrical energy to the circuit. It is represented by a thin long line is positive terminal and thick short line with negative terminal like this. This is the symbol. Plus, minus. So long line indicates positive, short line indicates the negative. That is one of the first component of the electric circuit. Okay. The second one is plug key or tap key. That is also called switch. Okay. The plug key or tap key acts as a switch. This also can use as to make or break. Make or break the circuit. What is the duty of key? It makes the circuit or break the circuit. Making means allowing the current to pass through. Breaking means stop the current. Switch on, switch off, right? It will do both the versions. Either make or break the circuit, right? Then third component is bulb. Bulb is again consumer, which utilizes the current. Consumer, right? So it is a component which converts electrical energy into light energy. When you are supplying current, the bulb will give the light. It is a circle of an upgraded down U in it, like a line with the little bump in it. So symbol also. Okay, then find resistance. It consists of flow of current in a circuit. It is represented by zigzag line. So like the zigzag. Just like a speed breakers. So what is the resistance? To control the flow of electron. Then a fuse, very important one. In our every house, we have the fuses. Why are in fuses? To control the high voltage. Whenever high voltage comes, the fuse will burn and stops the current so that our electrical appliances are safe. If not, what happens? When fuse is not there, directly they come to our house and all the appliances will damage. Right? So fuse is generally made up of a material with low melting point. Okay. So these are the all components of electric circuit. In circuit, we have to use all these things. All these things makes one circuit. If you go to the industries or domestic house also, we can find the electric circuits, right? Then these electric circuits can be two types. One is open circuit, other one is closed circuit. Open circuit, closed circuit, right? See here. When a path which is from one terminal to another cell ends at the other terminal of the cell without any break, then such circuit is called complete circuit or closed circuit. Circuit is closed means current is passing. Bulb will glow. Closed circuit is nothing but where there is a continuous flow of current. Means switch on. So closed circuit is switch on. Open circuit is switch off. When switch on, what happens? Bulb will glow. When switch off, bulb won't glow. Means there is some disconnection. Means there is switch off. So switch off condition of a circuit where current is flowing is called closed circuit. Switch off condition is called open circuit. Right? Clear? So there are two types of circuits. That is simple way. Switch on, switch off. Only two are there for switch. When you on the switch, current will flow, bulb will glow. When you off the switch, no current will flow, bulb will not glow. That's all. So where bulb will glow is called closed circuit. Where bulb will not glow is called open circuit. Like that, there are two types of electric circuits everywhere. Right? Then another important thing is cell. I told already. Cell is a small bulb, you know, small one, small battery. What happens when cells are connected in series? Suppose this is cell, one cell, right? This is the one cell, positive, negative. You are connecting another cell like this. That is again positive, negative. Means end to end. One end of the cell is connected to other end. And another like this, three we connected. Right? And we are connected to say some bulb. So this connection is called, suppose each cell capacity is 1.5 volt, 1.5 volt, 1.5 volt. So what is the total here? 4.5 volts is we are supplying. So automatically bulb will glow with the more brightness. Whenever cells are connected end to end, one end to another end, the brightness of bulb is more. When one is there, the brightness is less. When second one is added, brightness is more. When third one is added, brightness is still more. Because the total becomes 4.5 volts of current or potential. Right. So when number of cells connected end to end, that is opposite terminals are connected, negative to positive, negative to positive. So see, positive to negative, negative to positive, like that kind. This arrangement is called cells in series. Right? Then what is the total current here, total EMF energy? So suppose say E is the current here, E1, E2, E3. So total E is equal to E1 plus E2 plus E3. Any number you add will get more. Suppose one more cell is added, 1.5 is added. Like that, every time you get the added, voltage is added to the cells, right? So 4.5 volts we got it. Next, second connection possibility is cells in parallel. What? Parallel. What is parallel? For example, you have one cell here, positive, negative. Again, one more cell is there, positive, negative. Again, one more cell is there, positive, negative. The connection is different. Observe carefully. All positives are connected to one terminal. All negatives are connected to one terminal, right? All positives one side. See, previously what we have done for this negative, we connected the positive. But here what we are doing, all positives at one end, all this connection is called cells in parallel. In this case, when you connect the bulb, it will go with the same brightness. Any number you connected, 1.5, 1.5, 1.5, but overall is 1.5 only. There won't be any change in the brightness because they are parallel to each other. So bulb will grow with the same intensity. But what is the advantage here? When bulb is in series, when one bulb is disconnected, when one cell is disconnected, other current won't glow. You might have seen the decorative bulbs. For decoration, we'll use the bulb, small bulbs. So in that any one side you disconnect the wire, remaining bulbs will not glow. But in parallel connection, not like that. If one bulb disconnect also, other bulbs will glow without any disturbance. That is advantage of parallel connection. Right? So that we learn more in the higher classes. When you go to next classes, 7th, 8th, 9th, we get details about what is the advantage of series connection, parallel connection and all. Okay. So see, a parallel connection is there. So there are what is the advantage and disadvantage of series circuits, parallel circuits are given. But before going for this, let me show you one video on the basics of the electricity terminology. After this video, we can go for the continuation of the topic, right? Observe the video very carefully so that you can get the more information about the electric current.
Probably the most famous experiment involving electricity, at least in the minds of American school children, is when Benjamin Franklin tied a key to the end of a kite string and sent it into the air during a lightning storm. The lightning struck the kite, traveled down the string to the key, proving that lightning is a form of electricity. Franklin also proved that objects made of metal, like the key, are good at conducting or easily passing along electricity. The story doesn't stop there, though. Franklin wasn't just outside in a storm with a kite and a key for no reason. He was looking for a way to reduce the number of fires caused by lightning. After proving that metal is a good conductor of electricity, he developed the lightning rod and placed these structures at the top of buildings to keep them safe from fire, which was probably good for the fire departments Franklin is also credited with developing. A lightning rod attracts the electric charge from lightning and conducts it by wire down the side of the house to a ground rod. This is something we in modern society somewhat take for granted, but that's because lightning rods have been installed everywhere for the very reasons Franklin were concerned about. Imagine you and some of your friends standing in a circle. Each one of you represents a single atom, the building block of all things, from apples to jet planes. Every atom has a nucleus at its center and is surrounded by a cloud of electrons. Now imagine each of you and your friends in the circle holding a single ping-pong ball representing an electron. If you were to pass the ping-pong ball's electrons around the circle, you would be replicating the flow of electricity. Electricity is when electrons move from one atom to another, in much the same way the ping-pong balls were passed from one person in the circle to another. The flow of electricity is called a current, which we measure in amperes, I, also known as amps. Conductors like Franklin's metal lightning rods easily carry electric currents, while insulators like rubber, wood, or cloth stop the flow of electricity. Besides measuring electricity's current, we also measure its voltage, watts, and resistance. The volt, V, is the power available to push electricity around a circuit. Think of it like the water pressure in a pipe. The more voltage you have, the more quickly electricity flows through a circuit. Resistance, to take the analogy further, would be pipe size and is measured in ohms, R. We measure electrical power in watts, which is obtained by multiplying amps by volts. In the 1700s, scientists got super into studying electricity. This was before light bulbs, televisions, and all the other.
So it is the old part, right? So anyway, so there is some problem, technical issue there. So electricity, clearly they explain how the electricity flows from one place to another place, and how the current will flow. Here we are continue to discuss about the what is the advantage and disadvantage of the circuits connected. Right, please. The study of the property of series circuit or parallel circuit. So what is the advantage, properties? So circuit, what is circuit here given? Materials required: a battery of 4 cells, 2 bulbs of 1 and 1 watt each, and fused bulbs and switch, few length of wire, connecting wire. These 4 are required. So this is the battery, these are the bulbs, and this is the switch here, and this is the wire. All these 4 are required for making a perfect circuit. So when you go for, there is a method. What method they are following? Connect the bulbs A and B in series. What is series? Positive to negative. Like that you have to connect. Connection is, you can see here. This is a series connection of bulbs to the battery and key. Right? A and B in series, connecting them to the connecting wires with the help of the cello tape. You have to apply cello tape wherever required. Connect the free ends of the connecting wires to the battery. So you have to connect to the battery here. Free end of this and free end of this. We are connected to battery in figure. Okay. Then through switch. Close the switch. Switch close means on. What do you observe? How the bulb will glow. However, they will not glow very brightly. Open the switch. What do you observe? Right. So both the bulbs will stop glowing. First time what happened? They are glowing. The glow is very less because there are 2 bulbs are there. Same current passing for 2 bulbs. So glow will be less. If 1 bulb is there, will go with the more brightness. But when you are connected 2 bulbs, the brightness will decrease because same current is passes. If you have 3, 4, 5, 6 bulbs, the glow will reduce. Both bulbs will step down. Now remove the bulbs B and instead of fuse bulb C, one more you are keeping. What is your observation? Bulb A not glow. So when disconnect one bulb, it will won't glow again. That is a disadvantage of the series connection. Okay. Now some more information. So following are the conclusions from the above investigation. See, in series circuit, all appliances work simultaneously when switch is closed. Conversely, all appliances stop working when switch is open. So in series circuit, if any of the appliances goes out of order, the other appliances also stop working. That is a disadvantage. When you connect the bulbs in series, if one bulb stop working, next one won't work. Remember, before one will work, but next one won't work because current won't flow there. So, as the bulbs were not glowing very brightly, it can be conjectured that the series connection appliance do not work to their full capacity. Now connect the bulbs A and B in parallel like this. Parallel you can see how such that they have common positive and common negative terminals. I told now all positive at one end, all negative at other end. As through a switch and battery. Close the switch. What do you observe? Both A and B will glow very brightly. Now remove the bulb B instead of fix fused bulb C. So same case we are repeating for the parallel connection. So what we observe here, in parallel circuit, all appliances work independently. in parallel circuit, if one appliance goes out of the order, the other continue to working. It means that each appliance parallel circuit can be operated independently by switch. Separately, suppose now one house also will have separate circuits. When one room current goes, we can enjoy the current in other room because we have separate fuses for them, separate circuit. Okay. We have separate circuits for them so that we can enjoy the current in the other circuit, other class, right? So like that, we have the parallel connection. As a bulb grows brightly, it means each appliance get enough electric energy and hence works to its full capacity. Right? So this is the advantage of connecting the bulbs or cells. First we have seen cells, now we have seen bulbs. What happened? The cells are connected in series, cells are connected in parallel. What happened when bulbs are connected in series and bulbs are connected in parallel? Both ways you connect the bulbs and cells. So this is our the synopsis 3, where we learn about especially about the components of electric circuit. What is electric circuit? What are the components of electric circuits? Right? And how these components can be connected. In that, there are two ways are there. One is connecting the cells in series and connecting the bulbs in series and parallel. Okay. So next class we'll discuss about the synopsis 4. But before that, so there are some explanation for the terms for the discussing about current. But before that, let me recall what we learned today. So first thing is, what we learned is electric components. So name important electric components. Components are number 1, source. Source means which gives the current. For example, cell is the source. Battery is the source. Right? And we have the inverter is the source. Generator is the source. Right? Transformer is the source. All these are comes under the source of current, the first component of electric circuit. The second one is consumer. Consumer is nothing but which utilizes the current. So first bulb, right? Fan, computer, right? TV, AC, geyser, whatever is there in your house which are using the current, all comes under consumers only. And third component is switch, very important. So switches, you know everyone, or it is also called as a key. Any number of switches you can use. And fourth important component is cable or wire, right? Cable or wire, which is generally made up of copper. Copper, that is conductor of electricity. So these 4 are named as a components of electric circuits. 1, 2, 3, and 4. Minimum these 4 components are required to make a circuit. There may be 100 sources. There may be thousands of consumers. There may be any number of switches and any number of cables. But minimum requirement is 1 for each. They are called components of electric circuit. Source, consumer, switch, cable or wire. Right? This is the home task today. Whatever the task is given for you is these 4 important components. What we learned today in the synopsis 3. You can note down also this. Write down please. Write down source, cell, battery, inverter, generator, transformer. Consumer, bulb, fan, computer, TV, AC, geyser, and many more. Switch is nothing but key, cable or wire, which is nothing made up of a conductor that is generally copper. Right? You can note down in notebook. Copper conductor. Even you can use gold also, you can use silver also. But as you know, they are very expensive. We cannot use them in the electric wire. But they are a very good conductors compared to copper. Okay. These are the 4 main important components of the electric circuit. Then what we cover now, next, after knowing about these components, we learn about the how they are connected, right? So note all these 4 points, very important. First, source identity. Name the cell, battery, inverter, generator, transformer. Consumer, second side heading, bulb, fan, computer, TV, AC, and geyser. Any more also you can write. Fridge also you can add. Laptop you can add. Mobile phone you can add. So after knowing about these components of circuit, we have seen symbols also. Symbols, there is a table is there, you can go through the material, how to represent cell, how to represent battery, how to represent bulb, how to represent fuse, how to represent resistance. Everything is mentioned there. So this is our first step to the test 6. So after writing all these things, you can take the signature from your teacher and parents, so that right. So after this, what do we have learned? Again, 2 more points we learned, very importantly. First one is cells in series and parallel, right? Then second one is bulbs. Bulbs in series and parallel. So what is the property when they are connected in series and parallel? We have seen. When cells are connected end to end, that is called parallel series connection. So cells can be connected either in series and parallel. Similarly, bulbs also can be connected series and parallel. Both are having their own advantage and disadvantages. So you will see for decorative bulbs, we'll use the series connection. Number of bulbs are connected in series to get the decorative lamps. But what is the disadvantage there? When one bulb is failed, so current won't flow for the next bulbs. But in parallel, not like that. It is independent. When one circuit disconnect also, other bulb will glow. So based on that, our domestic, our in home, all are connected in the parallel only. We all connect the circuit parallel in case of our domestic appliance. Right? So these also we learned in the synopsis 3. So cells in series, cells in parallel, bulbs in series and bulbs in parallel. What are their properties, advantages and disadvantages? Right? Done? So that's all for today. So tomorrow we'll continue with the more, that is next class. We'll continue with the more about the electricity and we'll try to close. We'll learn more about the very important terminology related to electricity. Right? So that's all for today. Have a wonderful day. So thank you, students. Thank you, all of you. So thank you, Gopal Nagar. So have a wonderful day. Thank you.